Sure enough, it looks like this. The data is not very clean, but you get the idea. So how do we go from here? The very first thing we do, divided by 1,000. Double click it. Next thing we do is calculate the velocity. How are we going to calculate the velocity? Displacement divided by time. Open parentheses, choose the one after, minus the one before, and you multiply, you don't divide, multiply by 100. Enter, double click. And I know the bottom, I already know that the bottom value is going to be wrong. That's why it's going to give me a spike if I was to graph that. And yes, sir.
Why is it 120 again?
Because when you divide it by 2 over 240, it's the same thing as multiplying it by 120. Right? 2 over 240 is the same thing as 1 over 120. When you divide by a fraction, it's the same thing as multiplying it by reciprocal. Okay. Yes?
So can you repeat how you did 8?
It's displacement divided by time. So it's this value minus this value multiplied by 120. Because there's 120 frames per, it's 240 frames per second.
And you divide it by 1,000
because we go from meters, I'm sorry, from millimeters to meters. All right, so that's the velocity, right? And you should be probably putting displacement, velocity, acceleration at the top. So now I'm going to calculate the acceleration the same way that I did this over here. And by the way, if you right click here and say copy, and then you can right click and choose the formula over here, it'll do it for you. Right? So you just paste in the formula. If I click in there, sure enough, it did what I wanted it to do. I just had to make sure to do it in between those other two. So that's another shortcut. So now that's the acceleration. Right? And from the lecture, you know that force is equal to mass times acceleration. So if I have the acceleration, I'm just going to put D, V, A. So, and I remember this was the 4. So this was the 4. This was the 4. So notice how this number is not changing, which means what?
That's his weight.
If the number is not changing, that represents the force. It means this person is standing still. Okay? So to figure out their weight, I know this is their weight. I'm 865 newtons, right around there. 865 newtons is their weight. To figure out their mass, I would need to divide by 9.81. So if I just take one of these values, divide by 9.81, this is their mass. It's in column L, row 2. So in order for me to do mass times acceleration plus weight, I would need equals mass, which is $sign L, $sign 2. That's their mass, multiplied by acceleration, which is right here, and parentheses, and then plus the person's weight. The person's weight, again, was 865 newtons. And you enter that, and double click it, and then graph it. I should get some things at the very end, like I said I would. So if I just go to the very bottom, shift and down, I notice that there's these last few. When you're dealing with 1,200 points, deleting 3 points is not a big deal at all, right? Because I know they're incorrect because they're divided by 0 and so forth. So when I go back up, there's the graph. Now, how do I make the graph a little smoother? I just simply choose to do what we call a moving average by adding 5 values and divide it by 5. And the more values you choose, the more it's going to smooth it. Plus.
You type average.
You can. Yes, you can. You're absolutely correct. Divided by 5. Now it's in column K, it's column, instead of column J, right? So another shortcut here is when you select your data and you edit it. All you have to do is change the two letter J's to letter K's. Or the other thing you can do is just shift it, grab it and shift it, it'll do that too. It's the other way of doing it, graphing it correct. And it looks a little smoother now, doesn't it? You choose 7 points and you smooth it even more. Now does that look anything like the one at the bottom? A little bit. Then you would put two of them in the same graph. All right, so to recap, divide by 1,000, calculate the velocity by doing displacement divided by time, right? And displacement divided by time. How much time is there between every frame? We collected at 240 hertz. So every single between frame 7 and frame 8, or between frame 1000 and 1001, how much time has elapsed between? And the answer is 1/240th of a second. That's how much time has elapsed. So, because velocity is equal to the change in displacement divided by the change in time, right? The change in time, when I'm choosing this cell and this cell, there's been 2 time sequences. So it's 2/240. So if you're dividing by 2/240, and 2/240 is the same as 1/120, it's the same thing as the change in displacement multiplied by the reciprocal of that. So that's why you multiply by 120. Okay? Because 1/120